All right, we are going to pick up where we left off, working on this counting method. That was a vertical line. We're going to do a horizontal line, and then we'll do the diagonal line. We'll do 3, 4, and then I'll leave 5 and 6 for you just for time purposes. And also for time purposes, we'll get right into it. And so same kind of idea, vertical line, we counted to the vertical line, and then we counted on the opposite side of it. And so same kind of thing, we're going to say this point right here is my starting point, and we want to reflect that point to the other side. And so we count 1, 2, and then we hit the line. And then we got to count on the other side of it, 1, 2, and now that point has been reflected over to here. All right, we'll do this point here, that red point now, and we count 1, 2, 3 to the horizontal line, and then 1, 2, 3 on the other side of that horizontal line, and that red point has been reflected. The blue point right here is 1, 2 reflected over, 1, 2, and we got right there. All right, last one, we'll do a purple point, and that purple point there, it's 0. It's already on the line, so that's 0, and so it stays there because that's 0. And now if we connect our shape here, we'll do it in green. Oh gosh, that is not looking good. We will do it in purple here again, and then I need to click a straight line, and we'll just drag it there. So you got one line here, one line here, here to, it's not going to be perfect, there to there, and there to there. And that shape has been reflected over that diagonal line. All right. Now we got to do horizontal. Horizontal is a little harder because that was pretty simple. We just counted over the line, counted on the other side, and it's nice, like either we're counting horizontally or we're counting vertically, depending on which line we have. Here we have to count diagonal, and so I'm going to call that's the counting method. Now we have a diagonal line here that we're reflecting over, so I'm going to call it the diagonal counting method. All right, and I'm going to try to draw this out the best I can. Again, I'm going to just go point by point and reflect each point. So we're going to start here with the green point. And the reason I call this diagonal, or the diagonal counting method, is because that's my point, and we no longer can count vertically. We can't count this one, and then try to reflect it this way. If we try to do it that way, it's going to get messed up. And so what we need to do is we need to count diagonal spaces. And so my green point is right there, and it is one diagonal space away. And I'll do it with a better line. I'll do it with a straight line. And so my point again is, sorry, didn't mean to put the point there. My point right there is green, and it is one diagonal space away. So diagonal counting method is one diagonal space away, which means you have to do one diagonal space on the other side. And so my new point for that green point is going to be down here. And we're going to do that with each point. So now we'll do a blue point up here. That is one diagonal space down to here. And so another diagonal space, my blue point is right there. And it looks like I'm going to have to connect blue and green. Okay. Red, a little tougher here. I'll count it out. You have one diagonal space right here. You have two diagonal space right here. And then you have half a diagonal space down here. All right, and so we have 2.5 diagonal spaces to move. So we go 1/2, 1.5, 2.5 out to here. And so my red dot goes out to here. All right, and we'll do that with each point. And I'm actually going to pause and finish this one up and show you what the reflection looks like. And after a little editing, you can see what this shape looks like when it was reflected over. The diagonal ones are definitely the trickiest. So hopefully after I paused and now show you the final piece of work, you can see how those dots moved. Again, just counting diagonals. So if I use that black dot, it was one diagonal, two diagonal, and then just traveling those diagonals across. Similar to what we did in the regular counting method. That one, again, a little more basic because you're just counting left or right or up and down. Here you actually have to count those diagonals, which means you get sometimes half or sometimes 2.5, 1.5. And so it's a little trickier. And so we'll do one more here with 4. All right, and we'll try to keep it quick so we can move on to the next one. My first one I'm going to try to reflect is this red point here. That red point is 1.5 away, diagonally, diagonal counting method. So 1.5 diagonal, and so we go 1/2, 1, and that red point reflects over to here. We'll do the blue point and we can kind of choose one here. We'll do the blue point here. That is 1/2 away, and so it's 1/2 over to here. We'll do a green point right here. That is, oops, that's not green. We'll do a green one right there. And that is 1 whole one away, a whole diagonal away, so we'll go whole diagonal over to here. And finally, we'll choose, we'll do a purple again. We'll do a purple point right here. And that purple point is 1/2 away, and so it's 1/2 on the other side. And if I connect this, I get the bottom half, which will be here, here, and just to finish out the shape, we'll choose, because it looks kind of funny right now, we'll choose a couple other points just to finish it up. We'll do these in red, and so that is 1, 2, 2.5 away. So that's 1/2, 1, 2 away, and so that red dot goes there. And here we have 1 and 1/2, so we go 1/2, 1, and you can see that our shape actually, when it reflects, is going to flip kind of horizontally over that line. And so we get a shape that looks like this. Again, that one's a little trickier. If you would like more explanation on that and maybe me to work it out a little bit slower, please let me know. I'm happy to send a second video just working on that one, or maybe on the other one that was the diagonal counting method. And I'm going to leave 5 and 6 for you. Please do it. 6 is easy. 5 is using the regular counting method, which is a little bit easier, and so give it a try and see if you can do it. All right, we only have 2 problems left. We have 152, and we have the learning log, and the learning log I won't write out, but I'll just show it to you. And so first here we have a good one, and I kept this one in because it always helps to work with our algebra skills. And for my sophomores, and even juniors, I guess, it's just never hurts. They're coming out of algebra, the sophomores are, and so they'll maybe have it fresher in their memory, but we did this problem as sophomores last year, so if we need to do it again here, it should just be, extra practice. So it says, what other ways can we do reflections? And so we're going to actually reflect a graph, and so we get that algebra connection. We have to first graph the parabolas y equals x squared plus 3 and the line y equals x for these given x points. And so I'm going to do an xy table just to kind of bring back how we do these graphs. And some people could maybe graph it just from memory, but we'll do y equals x is the first one, and then we'll do an xy table here. So x, y, my x's are -3, -2, -1, 0, 1, 2, and 3. And if y equals x, that means if x is -3, y is -3. If x is -2, we have this list here, which is just repeated, kind of reflected over there too, huh? And we can then graph that. So -3, -3, we got to go, if x is -3, that means we go back 3. If y is -3, we go down 3, and we have our first point there. And then -2, -2 down to here, -1, -1, 0, 0, +1, +1, +2, +2, +3, +3. And if we kept going, we would end up with a straight line, straight diagonal line. So maybe this will tell you we're going to be using the diagonal counting method here. All right, and that would be our line y equals x right there. Okay, the other one's a little bit not tougher to do it, but it's just a little different. So we have y equals x squared plus 3, and we got to do an xy table, x, y, and so -3, -2, -1, 0, 1, 2, 3. You're actually going to see some symmetry here, kind of interesting. You plug in your x here, and so -3 squared is 9, 9 plus 3 is 12, -2 squared is 4 plus 3 is 7, -1 squared is 1 plus 3 is 4, 0 squared is 0 plus 3 is 3, and then 1 squared is 1 plus 3, so 4, oops, and 2 squared is 4 plus 3, which is 7, 3 squared is 9 plus 3 is 12 again. And so we can then graph that. So we have -3, 12, so you go over 3 up to 12, and then you go, what is it, 2, 7, so -2 up to 7, -1 up to 4, 0 to 3, and then it repeats on the other side here. And so we get our parabola. Try to draw it as best as I can. All right. Now we need to reflect that over this diagonal line. And so we're going to use the diagonal counting method again. My first point was right here at 3. And so we're going to go over 1.5 down to here, half, 1. And so we're down here with the first point. This one here, we had that point. So we go 1.5, half, 1. We're here. And you might already start seeing a pattern. We go 1, 2, 2.5. And so 1.5, 1.5, 2.5 down to here. Up here, this is going to be the last ones I'll do. You go 1, 2, 2.5, 1/2, 1.5, 2.5 out to here. Here you go 1, 2, 3, 4, 4.5. So you go 1/2, 1.5, 2.5, 3.5, 4.5 down to here. And the reason that I'm saying you could catch a pattern is because we can see that same kind of symmetry. Everything just got flipped. Sorry about that. Announcement coming in. But we, again, just using that diagonal counting method, you get to see that that just flips over that line. And they ask this question, which is a really great investigative question. It says, now that we've reflected, what do you observe? What happens to the x and the y values of the original parabola? Well, they flipped. The y value here used to be 3. Well, now the x value down here is 3. The y value here used to be, or I mean, we could think of it like this. That space right there, that one right there is 0x, and so we got 0, positive 3 is the coordinate, and that coordinate right here is positive 3, 0, right? This one is 1, 4, so that point right there is 1, 4, because it went 1 to the right, up 4. Here, if we count that same point, which is this one right here, we went over 4, up 1. And so that changes to 4, 1. And so when you flip it like the diagonal there, and so we'll say it like this, x and y, and then you do the diagonal method, becomes y and x. It just flips it. All right, so when you flip it over the line, you have to flip the coordinate there. All right, that's kind of basic. We'll see more of that as we keep going. And please, again, if that's confusing, just let me know, email me, and I'll talk about it more. All right, the last one, we just have the learning log. I bring it up here just because it's the first one of the year, technically, and it just brings up the idea of it. And so it says, throughout the course, you'll be reflecting on your understanding of mathematical concepts, and that's why I find it important. All right, things will stick better with you if we reflect on it. And I know last year, if I have students that are repeating, or if you were in Leather's algebra or Duffy's algebra, sometimes we didn't always do the learning logs, or maybe you did back then, I don't exactly remember, but I know personally I need to do a better job with it. So please, for today, give me a learning log. We're going to try to stick on it because those reflections do help us in the long run. So these are the questions down here that I want you to answer, to reflect on. Please title the entry reflections and then include today's date, so if we need to go back, we can. Lastly, make sure that you read the math notes box. I have it through here, so maybe you can just repeat this part of the video to read it, because there is a problem on the homework that uses this idea. It's also an idea that comes up later when we start talking about probability. All right, that's all for this video guide lesson. Email me questions, please, if you have them.